Can you guys hear me? Welcome to week 9 problems NPTEL certification course environmental impact assessment being taught by Dr. Harshit Joshi session on Saturdays. I take the problem Saturday. I'm Isha Rathod, PMRF in this department of architecture. There is another problem solving session on Tuesday, which is being taken by Ms. Monica S. PMRF in this department of architecture and regional. So a few housekeeping rules. Please mute yourself for the session. If you have any questions, you can post them in the chat box. So please post any questions or answers you have in the chat box. I will moderate the chat box. And if you have any questions, since we are so few in number, you can just raise your hands and unmute yourself if you want to ask something at different points in the presentation. And so the outline of the session is that we're going to look up at the highlights from each of the week. That is, we're going to look up at all the lectures which were in week 9, and we'll also look at the key takeaways from each of the units and what was discussed in the entire week. Then we're going to look at some solutions to previous run of NPTEL course assignment questions with explanations, and we will also look up at assignment week 9 assignment because the deadline for the same has passed, and look up at these questions with their explanations. And if we received any queries from you in the discussion forum, we will also clarify these queries for you. So week 9 was about EIA reporting and review of the EIA quality. So moving to highlights from week 9. So lecture 41 was on EIA methods on ecosystem services. So this is part 2 of the ecosystem services module. Part 1 was covered in week 8. And so we looked up at scoping and baseline studies relating to ecosystem services. So ecosystem services review is also known as ESR. And again, this was a question in one of the assignment questions as well, I believe. And so, scoping and baseline studies look up at certain things. So these are entry points for the ecosystem service review, where such reviews are required, especially pertaining to ecosystem services. And then you also need to establish the scope for the ecosystem services review. And then you also need to look up at the sources of information which are available for doing a desk-based study, and to also look up at tools for scoping and baseline studies. That is, you need to decide your methods which you will use for doing the ecosystem services review. And you also have to develop your ecosystem service baseline assessment and look up at priority ecosystem services. We will look up at these in the next few slides. And finally, we decide the scoping and baseline assessment outcome. And so the scoping purpose is to establish that ecosystem services context for the planned project is based on the likely impact sources, and that ecosystems are likely to be exposed to change. So if these ecosystems are changing because of the new project, then you need to do this ecosystem service review. And if any of the beneficiaries of the ecosystem any of the beneficiaries of the ecosystem services, that is, people who receive these ecosystem services, are being affected, then also you need to do the ESR. And then based on these initial finding, you decide that the scoping phase should confirm that the proposed spatial scope or scale of analysis and the temporal scope, that is space-wise, what changes are being done and what changes are being done in a overall context. And then you also look up at the ecosystem services which these beneficiaries are receiving, and then you need to address them in the environmental and social impact assessment. So you need to look up at what services are getting impacted because of your project and which beneficiaries are getting impacted, and then you need to address their concerns in your ESR. So, for establishing a spatial scope for assessment purpose, you need to gather information on the locations of the plant development, infrastructure, and activities, and the associated zones of impact or effect distances. So these are areas. So of course, you have a site plan and you are making certain changes to the site, and then you need to look up at which zones or areas are affecting the ecosystem and or the ecosystem services and beneficiaries. So then you identify those zones and mark them as outline the effect distances. That is how much distance your development activity is impacted, like from how much distance to how much distance your ecosystem services are being disrupted because of the development in your site or project site. And then you look up at these distribution and extents of ecosystems that are getting affected, whether direct land use changes are going to happen, because in direct land use changes, you are causing indirect effects to the ecosystem because uh, the ecosystem which was already existing because of this particular land use is going to get disrupted. So, if direct land use changes are happening, then you need to identify them as well. And any ecosystems with functional connectivity, and if watershed is affected, then the entire watershed should be covered. And land use changes because of demographic change and improvement in infrastructure. Also, distributions of locations of beneficiaries of ecosystem services which are affected by planned development and infrastructure. So these are all of the things which you need to consider when doing the spatial scope or the space-based analysis for your ESR or environmental service review. Ecosystem service review, sorry. And then you need to look up at key information. So you can use satellite imaging or aerial photographs taken from drones or other sources. You can also look up at ecological assessments and reports which are available with different agencies which gather these data on ecosystem services and flora, fauna, and things like that. And then you need to specifically focus on these reports which focus on the particular ecosystem type, the distribution and conditions which your project is impacting, and then the threats and pressures which are affecting the ecosystem and how they have changed over time. So you can look up at the particular type of ecosystem which your project is affecting and look up at similar studies or assessments being done by different agencies who work in the ecosystem services domain. And then you can also look up at reports and information on plan development and the design and locations of planned infrastructure and activities. So you can look up at case studies where such type of developments has also happened, similar to your project or what your proposed project is doing, and then how they have tried to tackle these changes to ecosystem which their project have done at that point of time. So you can use inspiration from those reports as well and look up at how mitigation efforts were being planned around these impacts. And then you can also look up at social reports and results of initial stakeholder engagement or consultations. So these are demographic, cultural, economic, and characteristics and use of dependence on natural resources and ecosystems. So you can look up at the stakeholders or the beneficiaries of the ecosystems which are getting affected and look up at their profile in terms of the demographics, the population, what type of community they are, how they're getting affected, what sort of cultural background they come from, whether they have any particular cultural value they assign to a particular ecosystem services. Of course, ecosystem services have different type of characteristics. That is, there are different categories of ecosystem services. So in the recreational services, you have the cultural aspect of an ecosystem services. So if your development project is causing a harm to that, you need to look up, especially because culture is a very uh, like a very rigid aspect for certain communities. So you need to address that with that sensitivity in your mitigation efforts. And you also need to look up at the economic status of these people or their dependence in the on these ecosystem services. So all of these information you need to gather. And then you can of course look up at so different ecosystems have different type of benefits. So you can, so for example, you have grassland or wooded grassland is associated with wildlife tourism, livestock production. Communities can also depend on fresh water and wastewater treatment and things like that. And then you can look up at beneficiaries like, so wildlife tourism has beneficiaries like tourism operators who make their income out of the tourism activities like guides or local groups. And then you have the tourists who are coming to visit, how they are going to be affected, whether tourism numbers will fall down because of your proposed development, whether they will feel like the ecosystem is not as natural and it's not a good place to visit now. So those sort of things you need to consider again. So tourists are also a beneficiary. So then you need to look up at the different aspects that your project will have. So similarly, you can look up at benefits like income will get affected, the satisfaction will visit with the visit will get affected for the tourist. So things like that. So this is how you form a link between ecosystem services, and the beneficiaries and their benefits, and then you need to address them in your mitigation efforts. So then you can also have network diagrams for effectively understanding and communicating the impact. So you can have, so for example, for the development of a rural road project, you can see that ecosystems components like land and soil, forest, and air and water are going to be affected. So these are the components which are getting affected. Then the effect in terms of ecosystem services, that the conversion of arable land, that is land which was fit for agriculture, will be affected because of road construction, and this will result in the, so this is the impact, so this was the ecosystem service. Then this is the impact that it will decline in the crop production, and this will lead to migration of the people who were practicing agriculture in this area. And then for forest, you can have the impact or the service which is getting affected is the loss of forest area or species habitats, and this is further causing soil erosion and downstream sedimentation. This is also ecosystem service in terms of like the one which sort of facilitates the proper functioning of ecosystem. So this is also a ecosystem service, and this will lead to loss of endemic or protected or endangered species, which will cause the change in productivity of terrestrial, aquatic, and man-made systems. So again, you need to look up at the different. You need to form these links between the ecosystem type, the ecosystem service which is getting affected, the beneficiaries, and the potential impact on the beneficiaries. So you need to make that connection in terms of understanding how your project is going to affect these ecosystem services and their beneficiaries in your scoping studies. And then this is also another system, so you can have like a causal chain network. So again, these are the action which your project is, which you're doing in your project. Then this is the ecosystem function which is getting affected by the ecological indicators like loss in biodiversity, for example, or loss of arable land in the previous case. And then the ecosystem service, like the benefits which are relevant to benefits relevant indicators in terms of economic and social value, and then how the social value or benefit assessment can be assessed in terms of a qualitative numbers. So these are again examples of the same. And then, so for the next step is, of course, doing the ecosystem service baseline assessment. And for doing this, you need information around the current level of ecosystem service, the supply, use, and benefits. So we looked up at the definitions of all of these concepts in lecture 40. So you ideally you should have a balance between supply and use. Otherwise, you have a lot of ecosystem service being available and it not being uh, received. Do you have a question, Ushman? You can unmute yourself and ask, or we can take the question later as well, because your hand is raised, so I thought you have a question. Okay. So moving on, then you also need to establish the relationships between supply, use, and benefits, and if any future supply and use in the absence of the planned project, taking account of existing threats and pressures and their relationship with people's livelihood, health, safety, and cultural benefits. And then you can look up at you can look up at secondary data like land cover, land use mapping, uh, the vegetation survey, and is it better now? Hello, is it better now? Okay, so and you can have survey of biodiversity and ecosystems, the botanical surveys, agricultural surveys, how agricultural lands are getting affected, what sort of soil, what sort of crops are being grown, what sort of seasonal pattern of crops is being observed, and things like that. Then you also have social impact assessment and results of stakeholders, how stakeholders or beneficiaries are getting affected, and what is their demographic profile, economic status and things like that, whether they have any concerns initially when your project was introduced, health impact assessments, if the project is causing an impact to the health of the beneficiaries or people around it, then you need to do health impact assessments as well. Then you can also have livelihood surveys, water studies for assessing the quality and quantity effect on the water present on site and the other water sources around. And then you have something called as INVEST, which is Integrated Valuation of Environmental Services and Trade-offs. So this is a model which is used to map and value the goods from nature that sustain and fulfill human lives, and it helps to explore how changes in ecosystem can cause many different can disrupt the flow of many different benefits to the people. So then you have sort of an assessment of how your environmental services are getting affected and what sort of trade-offs you can do for making your project viable to this ecosystem service review. So invest is this model which helps you in having this trade-off between the uh, environmental service impact and the environmental mitigation which you can do. And then we had the priority ecosystem services. So priority ecosystems are those from which changes due to a project are most likely to affect the well-being of beneficiaries because they depend on them to a greater extent and have limited or no alternatives. So for example, if your project is so for example, the case of the rural road development. So if the community around it has is primarily getting their income from agriculture, and if the conversion of the agricultural arable land to the road development or the infrastructure land affects them directly and in the most great extent, which is that their livelihood is threatened. So this is like a priority ecosystem service which is getting disrupted, and they don't have any alternatives apart from migration or moving to another community, which is again a lot of hassle for these people. So this is a priority ecosystem service, and you need to identify these priority ecosystem services in your assessments as well, where the direct impact uh, of a of your project or the activities causing the greatest extent of damage to the beneficiaries. And then you have the priority ecosystem services. So you can look up at the decision tree where you identify priority ecosystem services and how they are affected by the project. So you can ask the questions like, can this ecosystem service reasonably be expected to be affected by the project? If the answer is no, then it's a non-priority ecosystem service. If the answer is yes, then you need to look up at, is the benefit obtained from this ecosystem service likely to be affected? If your answer is yes, then you move on to the level of dependence of this ecosystem services by the beneficiaries. If it's high or moderate, then you consider if the beneficiaries have any other second alternative or a secondary or a satisfactory alternative. If they do not have this, then it is a priority ecosystem service, like in the example we discussed previously. And then, so for doing the engagements with these stakeholders, so that you can identify these sort of ecosystem services that contribute directly to their livelihood or their well-being, and then you establish how these ecosystems and services are used and determine whether different stakeholders use these services in a different way. And then you identify the use shed, that is where people access the ecosystem service that they depend on. And if your project is directly affecting that use shed, you need to change your action which affects this use shed. And then you also look up at to establish the extent of use and dependence and benefits which are derived from the ecosystem service, and engage in discussions of alternatives with these stakeholders because they are directly getting impacted by the project's actions. So that is how you deal with priority ecosystem services. And then we move on to the outcomes of scoping and baseline studies. baseline assessment. So in the outcomes, at the end of scoping and baseline, you present the list of ecosystem services which were considered and which were identified as being affected. And then you look up at the stakeholder discussions and in what stages these discussions were done, and the assessment process, which was used to confirm whether these ecosystem services are most important or whether they are the priority ecosystem services, to determine the user's dependence and availability of alternatives. And then you present the understanding of the ecosystem, their types and conditions, and changes in supply because of your project. Because of your project, by doing an analysis of if your project was there and if your project was not there, what changes will be there. So you do that sort of assessment, and then you also have this understanding and present this understanding in terms of the level of use and type and the level of benefits which are derived from ecosystem services and the changes in use and benefits if this project was not there. So these are the outcomes which you present in your scoping and baseline assessment finally for ESR. And then, okay, so these were the steps again for the scoping and baseline studies, and we covered all of them. So, moving on, so now you need to do impact prediction and their evaluation. So again, impacts can be of two types. You can have direct ecosystem change, and then you can have indirect ecosystem changes because of your project. So direct changes are like changes in local land use, local land cover. Then in terms of harvest and resource consumption, direct pollution, species introduction or removal of species from the project site, climate change, and then you identify the impact on ecosystem in terms of types and conditions, and the impact on ecosystem service supply in terms of quantity, quality, timing, and location, and this impact on this ecosystem service in terms of uh, in terms of impacts on beneficiaries or the affected stakeholders. This is in terms of livelihood, their health or well-being, safety, and cultural. Again, culture is a very important factor and has to be dealt very sensitively in your mitigation efforts. And then indirect changes because of project can be the socioeconomic change because of certain communities moving out who are dependent on a particular service, but because of your project, the service is disrupted. So the social economic status of this area changes because that community migrated. And then in terms of economic change, whether your project is bringing in revenue or it is depleting the environmental value associated with the area. In terms of governance change, in terms of technological change, and cultural and religious changes. And again, you need to identify these impacts on the ecosystem and the impacts on the stakeholders in terms of the use and supply. So these are the same thing. And then, so that was all about ecosystem service review. And then let's on coastal ecology and geomorphology. So this is part one. Lecture 43 is part two. So we have certain definitions and concepts relating to coastal ecology and geomorphology. First is the coastal zone. So we have different coastal zones. So for example, we have the coast at the far end, and it can have dunes and other things. And then you have the coastline that separates the coast from the other coastal zone features. Then you have the backshore and the foreshore. This is again based on the sedimentation deposition and how high your tides rise. So these are defined by that. Then you have the beach phase, which is again where the water level comes, or the shoreline line. Then you have the low tide shoreline and the high tide shoreline. So the high tide shoreline determines the is the differentiating factor between the backshore and the foreshore. And then so this entire area from low tide shoreline to coastline is the shore. And then near shore is covered with is from the low tide shore to the offshore line, and then you have the offshore. So these are the different coastal zones. These are again based on certain definitions and the in terms of the distance benchmarks, which we have not covered here. And then these are again the same things, but then you also have these three types of uh, zones which are related to pristine mangrove tidal zones, where mangroves grow. So mangroves grow in a very waterlogged area. So you have three types of zones. So you have the sublittoral zone, the intertidal zone, and the superlittoral zone. And then we will look up at them in the next slides also in terms of what sort of features they have. And then in terms of the information needed on coastal geomorphology and various habitats, you have you have to have reasons for doing an assessment on coastal geomorphology. So again, these are done in regions where geomorphological landforms and processes are integral to the coastal ecosystems, and whether when there is a direct relevance to the risk of coastal erosion and flooding happening because of the project. And any change which can lead to direct or indirect impacts is considered in this case. And then you need to do two sort of information gathering for geomorphological EIA, which is you need to gather the information on the process and the material. So for the process, you need to look up at the winds, waves, tides, the tidal currents, sea level change, and the trends, directions, and variabilities with time. And in terms of the material which you need to gather for geomorphological EIA, you need to have the material relating to the geology of the coastal zone, including the rocks and the formations and the softer sediments knowledge. And then you also need to understand the topography and the bathymetry, which is underwater topography, and the type of mud, sand, gravel. And then you also need to look up at these distribution of mobile and non-mobile sediments. Of course, water carries sediments with them as they come and move. So you need to look up at whether these sediments are movable or they have settled in the coastal area for a longer period of time now. You need to have these information on process and material for doing the coastal geomorphology EIA. And then you also need to understand the interaction between the material and process at the land-sea interface. That is where the land and sea meet. So you need to understand the nature of erosion, if it's happening, how sediment transportation and deposition happen, in what periods it's strongest, and what sort of sediments wash up, how it affects the shoreline and things like that. And then you also need to understand the spatial and temporal changes in these processes. And then these are again so you have the various habitats which are found in the three types of zones which we looked up at in the pristine mangrove region. So you have the sublittoral zone which have a very high tide location, and then you find a different type of species, and then you have the littoral region, which is the region between the lowest low tide and the highest the high tide zone. So you have certain type of species which are again found here, and then you have the sublittoral species, which are sublittoral zone, which are again the species which are found on the seabed, and which are very less affected by direct interventions. But of course, interventions cause indirect effect to these zones. Project actions cause uh, uh, indirect impacts on these zones. And then, so these are the typical locations and relationship between the three types of habitats which we saw. So, in terms of the coastlines and headlands, the littoral zone have very rocky shores, and the superlittoral zone have coastal cliffs and slopes. So you have superlittoral is the first zone which you see, and littoral is the second zone. We have not considered sublittoral in this assessment. And then you have different type of exposure to coastline. So you have beaches and you have vegetated shingle beaches. And then, so these are different things which you can look up later as well. And in terms of other information that you need for doing a coastal geomorphology EIA, you need to understand the seabed habitats, which exhibit variation because of the substrate, the water movement, the salinity or the soil content present in the waters, the turbidity or the clearness of the water, or how muddy it is, the temperature and water clarity, topography and the currents, the light, whether it reaches to the bottom layers or not, and if it's affected in the winter period as well, and then the geothermal activities, that is the warming up of these water uh, because of the earth temperature rising. And then in terms of doing scoping for coastal geomorphology or coastal studies, you need to include the impact area, that is the habitats and species which are directly or indirectly getting affected. You need to understand the study areas or impact sites, the survey requirements and timings, and you need to look up at the existing baseline data and need for detailed studies. Then you also need to look up at modeling these coastal processes, and if this is required in the first stage, and if it's required, what sort of methods you're going to use or what sort of models you're going to use, and then assessing the magnitude and significance of the impacts of your project on the coastal impact areas which were identified, including the total effects and the residual effects. And then you have these few agencies which you can use for gathering your secondary data. So these are institutions which gather data on different coastal parameters. So you can look up at these institutes again. So you have the Central Inland Capture Fisheries Research Institute. You have the Central Institute of Brackish Water, Aquaculture 141 Marshall Road, Egmore, Chennai. So this is an institute which is in Chennai. You can visit them to get data. You can ask them for online archives which they have and access to them. Then you have the Central Marine Fisheries Research Institute, which is in Cochin, also known as the CMFRT. And for getting this baseline data, you can also look up at aerial photographs or other type of photographs taken from drones and things like that. You can also look up at satellite data, the topographical maps, and bathymetric charts. And then these are again certain other institutes like Department of Ocean Development. So these agencies gather different type of data. So you can go through them into detail what sort of data they gather. And then for doing a baseline study survey for geomorphological and ecological surveys relating to coastal systems, you can use the tidal current meter and wave stations. You can use sediment sampling where you gather sediments, the samples of sediments from different points, and then you assess them in labs in terms of what are the constituents, what are the major sediments found, and whether they are mobile sediments or not. And then you also have the laser-induced direction and range, which is the LiDAR, which is most frequently used. And then you also have the aerial photography, which is for the very first initial level survey. And then you also have the wave data recording and processing techniques. So you record the wave data in terms of the different parameters relating to the wave characteristics, and then you record all of this data over a period of time, and then you process this data based on the time duration in terms of statistics, how this data has changed, and how this is going, how your project is affecting this sort of data, or will affect this sort of data. And so there are basically two main techniques for doing bathymetric for collecting bathymetric data. So this is a single beam echo sounding, and you have a multi beam echo sounding. So echo sounding is done to get, so you send a beam of you send a beam and then it echoes back when it hits a solid mass. So this is done in geomorphological surveys where you have rock masses and you need to identify. Of course, you can't keep diving in and gathering all of this data. So you use beam echo to get the understanding of the sort of landform which is underwater. So you can do a single beam where one beam is sent, or you can do multi-beam where multiple beams are sent to improve the accuracy and efficiency of the data which you gather. So you have two types of techniques for bathymetric data collection. And then for habitat surveys, you need to, of course, look up at the surveys and the different habitats which we identified previously, and look up at how you're going to map them, what sort of techniques you're going to use, what sort of scale of study you are doing, and what areas are being included. Then you can either go for the remote sensing and aerial imagery in the initial run. And then you can, in the initial run, after the initial run, if you require the need for detailed studies, you can do ground truthing, or you can basically study detailed do study detailed studies of it by using substrate sampling and other large-scale information gathering techniques to identify the habitat types and how what sort of effects could happen there. And if you are doing a study at a smaller scale, you can look at where detail is required or not. And then you can do walkover surveys for coastal habitats and intensive sampling for the marine sublittoral habitats, which are further below. And then, so that was what is covered in part one of the coastal ecology and geomorphology. So moving on to part two, which is lecture 33, which is again on coastal ecology and geomorphology. Now we look up at the sources and types of impact on coastal areas. So the key approach to identify impact is to consult with the public, the local stakeholders which are present on site and whose livelihoods depends on these areas, like fishermen and local communities who are dependent on the coastal waters, and the tourism of the coastal area if it's a tourist place. And then you need to also use or consult with key marine users or people who do research in these areas, how they're going to how their research is going to affect if such a project comes up. And then you also have regulatory authorities, like the authorities which are gathering secondary data. So you also need to consult with them whether you're in terms to identify the impact. And then you need to review the survey data in similar cases to look up at the project impacts. And for coastal ecology, there are basically two areas in which assessment is done. One is the hydrodynamic effects, and the second is the ecological impacts. So the hydrodynamic effects and ecological impacts are assessed in four steps. So these are So the first step is identification of the effect and the potential impact this effect is going to have. The second is describing the effect and the impact. The third is assessment of this effect and impact on, again, on the coastal areas or the impact areas, and then assessing the significance of these impacts, significance and magnitudes of these impacts based on certain parameters and benchmark values. So these are again some sort of examples on what sort of causes lead to primary and secondary impacts. So, for example, urban, industrial, and commercial development can lead to local increases in water temperature, and this can cause changes in the uh, biological composition of the coastal area. This can also cause loss of habitat, the habitat fragmentation, where the construction area fragments two types of ecosystem, creates like two or more segments of ecosystem, and it also causes edge effects, where the area occupied by the ecosystem shrinks because of the edges being unapproachable. And it can also cause damage to littoral and sublittoral habitats. The land take, drainage schemes, flooding can increase, erosion can happen, disturbances to species can happen. And again, tourism and recreation can also cause these type of effects. Construction of sea defenses or walls or hard structure, harbor walls or barrage schemes can cause flooding or waterlogging issues. It can cause change in the properties of the water, change in the biological constitution of the coastal region, and things like that. So again, all of these, you need to identify the cause of the project and what sort of impacts it will have directly and indirectly. So these are some of the examples of causes. You can go through them. I went through a few of them. And then you have certain other things like offshore oil and gas exploration, which can cause pollution, increase in the chances of oil spills, which are major accidents, and which are very hard to clean up after they have happened. As we looked up in the first few lectures where we talked about the different oil spill accidents which have happened. So that is one direct effect. And this can again cause damage to the ecosystem, especially animals, and bioaccumulation of toxic chemicals in the water. So of course, water and oil do not mix. So it forms this layer of oil on water, and it's very hard to clean up for the agencies and for water action agencies to clean up. So this is again a major risk and a major direct impact which can happen. And then different other causes and effects, you can go through them later as well. And then these are some of the things which we discuss again. So urban development can cause runoff, soil erosion, nutrients and toxic pollution, which can further cause bioaccumulation of toxic chemicals in these species, water species, and eutrophication or the growth of uh, excessive growth of plants and nutrients because of the excessive nutrients being present in the water. And oil and gas exploration, of course, have the disturbance to local species and ecosystem because of the processes of getting oil and gas out of the earth core. And it has the greatest hazard related to accidental release of oil or chances of oil spill. Then you can also have impacts because of construction of a wind farm, which can cause sediment plumes or sediment uh, if you have wind farms, the wind movement can cause sediments to have a movement without being taken by water, but by wind because of the forces of wind which is being generated because of the wind farm, and certain other things like disturbance and small scale loss of habitat, increase in underwater noise levels, disturbance effects to fish and marine animals, and things like that. So these are again impacts which you can consider based on the source and type of the action which the project is causing. And then you have certain sort of scoping guidelines for the environmental impact projects, especially relating to coastal ecology and geomorphology. So these are again, so for example, for water, you have groundwater hydrology, and you have different phases of these construction activities, and you can see how what sort of impacts and effects are coming up because of a particular activity happening at the different stages of the project. So I will not go further into them as well, but you can look up at these sort of impacts. So these are the sort of uh, assessment or tables which you need to put up and to demonstrate the effect that your project is having on the different components of the coastal ecology, be it water, land, biology, uh, flora, fauna, and things like that, and at different stages. So you need to document all of these changes based on the guidelines as which are available. Again, on air, flora, and fauna. And then we also looked up at the methods of impact predictions and assessments. So there are different models for prediction of impact. So for example, for noise environment, we have the Federal Highway Administration model, which talks about the noise impact because of vehicular movements on highways. We have Dhwani, which is a prediction of the impact of noise from different sources in an industrial complex. Then you have hemispherical sound wave propagation airport model, which identify impacts because of point sources or single noise sources, and especially for predictive impact around traffic on airports and railroads. So these models can be used if your area falls in any of these things. And then for water environment, we have the estuary models or the estuarial dynamic models, which simulates the behavior of tides, currents, and discharge in the water bodies, and which are again excited because of the ocean tides and the hydrological influx and wind action together. So you can simulate all of these parameters. So this is a dynamic model where all of these different parameters can be simulated together and the impact can be studied. Then you also have another dynamic model, which is the dynamic water quality model, and this simulates the mass transport of conservative or non-conservative quality constituents relating to water. And this can model up to 10 independent quality parameters. Then you also have the HGC2, which compares water surface profiles for different water channels and different water flows. And then you have the SMS, which is lake circulation for evaluating the lake circulation, saltwater intrusion, surface water profiles, and simulating all of these things. So this is again a subsurface modeling system. So you can understand what sort of models are being used for what sort of purposes. Then for land environment, we have digital analysis techniques, which provides the land use and the land cover distribution. We have the ranking analysis for soil suitability criteria, so where suitability criteria for development construction activity can be ranked and assessed. So this is again done based on different parameters like depth, texture, slope, erosion, geomorphology, and other things. So all of these assessments, particularly relating to the coastal aspect, is needs to be modeled to understand the um, effects of the project actions on water, land, noise effects, biological environment effects. So again, these are different models. So we have looked up at these different models at particular intervals of the. So, for example, when we were talking about land and when we were talking about EIA methods for water, we looked up at all of these models. We are just again putting them together to understand how these same models can be applied to the coastal region as well for assessing these particular areas. Again, same type of models for fauna. And then in terms of assessing, so you need to assess the magnitude and significance of your effect. So magnitude is the quantity of your effect. So again, magnitude can be analyzed in different categories like high, low, medium, insignificant, or relatively low. And then significance is how significant uh, these effects are to the for causing harm or risk to the ecosystem. So again, significance are again in the same broader categories. Of course, we have different sort of parameters or benchmarks for assessing the magnitude and significance. So for assessing the magnitude, we need to look up at the scale of the effect, the spatial extent, or the region, the geographical region which is being affected because of the effect, the duration of the effect, whether it is long term, short term, irreversible, so reversibility, frequency, how likely this impact is going to occur, whether it's going to whether it's a one time effect or it will keep reoccurring every time there's a high tide, every time there's a low tide. So you need to assess the frequency of this effect happening in the longer and the shorter duration. Then how vulnerable this effect makes the communities and people dependent on the coastal region, the sensitivity and intolerance, the recoverability or falling back to the initial stage when such an effect happens, how fast people can recover from this effect, the value or the importance of the effect. So these are certain aspects on which you define the magnitude of the effect. So again, magnitude can be high, medium, low, and there are certain criteria. I've just looked up at high magnitude. So high magnitude criteria is when the quality and availability of habitats and species are degraded to a larger extent, where rare populations and habitats are destroyed and protected species and habitats experience widespread change, and the integrity of ecosystem is compromised and the conservation status is also compromised. And then activities which are predicted to occur on different receptors or people who are dependent on the coastal ecosystem. This keeps happening over the longer term and during sensitive time periods, and it occurs every 10 years, and the impacts are not limited to the area within the adjacent, which is adjacent to the development. So this is the criteria for determining the high magnitude impact. Similarly, you have different criteria for a moderate impact, for a low impact, or a relatively insignificant impact. So these criteria are same, and similarly, you have criteria for sensitivity analysis. So in sensitivity analysis, you look up at two things, which is the value of the effect and the sensitivity of the receptor population. So for a high significance impact, we have the features or the receptor possesses key characteristics which contribute considerably to distinctiveness, rarity, and character of the site receptors. And these are designated features of international or national importance. So we have different conventions which protect watershed areas. So if the effect has a very high value damage, whether it's an international value associated with the coastal zone or it's a national value associated with the coastal zone. So that is a high significance impact. Then if these features are if these receptor populations have very low capacity to adapt to such sort of effect or to recover from them very fast, these populations are highly sensitive to this change. In that case, also this is classified as a high significance impact. So again, significance is based on two things, which is value and sensitivity, whereas magnitude is based on a whole different number of effect aspects, which we looked up in previous slides. And again, these definitions are in the category of high, medium, low, and significantly rare or insignificant effect. And so that was all for coastal geomorphology and geology. And then lecture 44 was on the IEA methods relating to noise. So we looked up at the principle of vibration, which is that simple vibration causes displacement of air particles around it, which reaches your ear. So you hear somebody speaking and what they are saying. So this is the principle of vibration, that is a vibrating object or the source of sound produces these movement of air molecules or vibration of air molecules, which is again compression and expansion sort of uh, curves and things. And then when they reach your ear, you understand sound or noise. And then these vibration frequencies, which are perceptible to humans, are in the range of 1 to 80 hertz. And these particles vibrate vertically and longitudinally, horizontally. And vibration levels are quantified in AISA reports in terms of peak particle velocity. This is measured in millimeters per second. And the threshold of human perception of vibration is typically within the range of 0.14 millimeter per second to 0.3 millimeter per second peak particle velocity. So PPV is peak particle velocity, another term to add to your list of abbreviations. And then we looked up at basic concepts of acoustics and definitions like noise. Noise is unwanted sound. Noise impact assessment is around the notion of quantifying and objectifying the personal and subjective responses to sound. And sound consists of pressure variations, which are detectable by a healthy human ear. And these pressure variations have two characteristics, which is the frequency and the amplitude. So frequency is how quickly the air vibrates and how close the sound waves are to each other. That is, and this is measured in cycles per second or hertz, Hz. And audible frequency is the lowest frequency which is audible to humans in approximately 20 hertz, and the highest frequency is 20,000 hertz. Amplitude is the magnitude of the sound. And environmental noise is defined as in a broad band, which includes a range of different frequencies. So environmental noise sources can include things like turbines, compressors, cooling fans, or transformers, which generate noise. And this is with discrete frequencies that produce distinct tonal characteristics. The audible frequency spectrum is divided into standard octave bands of 32, 63, 125, 250, 500, 1000, 2000, 4000, 8000 hertz. So these are the frequency spectrum. And sound amplitude is the amount of pressure which is exerted by air, which is often visualized as the height of the sound wave. So when we looked up at the curve of in the previous slide, so the highest point is the amplitude. So this entire distance is the amplitude between the wave. And this is amplitude is measured in the units of pressure per unit area, which is micropascals. Uh, and the amplitude is usually converted to sound power, which is in picowatts, which is 10 to the power minus 12 watts, or sound intensity, which is 10 to the power minus 12 watts per meter square. And then we looked up at sound intensity, which is the subjectivity of sound being felt in terms of the loudness of sound. So different people have different perception of sound, but we measure sound intensity based on the amplitude of pressure fluctuations and a standard lowest audible sound frequency. So sound pressure is measured in decibel, and this is given by the following equation, which is 10 into log 10, log base 10 uh, uh, into P by rho square. And rho is taken as 20 micropascal, and P is the amplitude of pressure fluctuations. So you can expect numericals around these noise parameter calculations. So you can remember these equations. So this is sound intensity. And sound power level is again expressed in decibels, and this is given by 10 log into log to the base of 10, W by small w square. And W is the sound power, whereas small w is 10 to the power minus 12 watts. So sound power level is the energy output of a source, which is calculated from measurements made around the equipment under carefully controlled condition. So it measures the energy output, which is being required to produce that sound. And then we have how to measure the noise characteristics. So we have metrics for characterizing noise over time. So we have noise levels are rarely steady and they keep changing, rising and falling in accordance with the activity which is taking place in a particular area at a particular time. And so in principle, you measure environmental noise in equivalent continuous noise levels, or the EQ. So EQ is on the as a subscript, which is the equivalent continuous noise level. And the LAEQ is the notional steady noise level, which is calculated over a given time, which was produce the same amount of energy as any time varying noise source. And this is calculated by averaging the sound pressure, power, intensity measurements with a bias towards louder noise effects. That is now louder noise effects are considered to be more powerful, and converting the average into the decibel scale. So you have calculations around this as well. And then there are certain factors which influence noise impact. So these are the level of sound, the context or location of the sound, the distance from a source of sound, the wave expansion pattern, whether it's being generated from a point source or a line noise source, the presence of obstruction. When there's a obstruction, sound gets diverted, because again, this is based on the wave theory. So any obstruction causes a disruption to the sound movement. So, and if sound is traveling over a reasonable distance, the type of ground over which it is passing can have a substantial influence on the noise level of the receiver, whether there are acoustically hard surfaces present, whether there are meteorological effects which cause sound to have lesser impact or lesser intensity being felt by the receiver, and environmental conditions like wind velocity, direction, and temperature. So these are factors which affect noise. Now, moving on to scoping and baseline studies around noise. So there are a few guidelines which are available, which are around noise analysis. So we have the Federal Highway Administration, or the FHWA, which has a noise abatement criteria, or NAC, which is around the procedures used in planning and design of highways, and they have a special or the supplementary appendix which talks about detailed noise analysis. But this is specifically around the development of highways and the noise caused during the construction of highway projects. Then we also have the CPCB guidelines for noise. So CPCB is the Central Pollution Control Board, which is a which is a regulatory body for measuring air and noise pollution in India. And then so they have the Pollution Control Acts, rules, and notifications which are around, which include noise pollution effects as well. Then we have different perception scales for sound or noise. So we have the perceptions like the sound is not noticeable, and then it is noticeable but it is not intrusive. That is, it can be heard but it is not causing any major disruption to the regular life activities of a person. It is noticeable and intrusive, that it is being heard and it is causing distractions and major attitude or behavioral changes. For example, if you have a procession or a uh, marriage wedding procession going on, you have very high perception of very high sound levels happening. Then you have noticeable and disruptive, which causes changes in the behavior and attitude of people, and when they have no other alternative uh, uh, to block this noise from coming. And then you have noticeable and very disruptive. So these are when you have extensive changes in behavior or inability to mitigate effects of noise, which leads to psychological stress or physiological effects being built up, such as sleep deprivation or awakening, loss of appetite, significant or medically definable harm that is to your auditory and non-auditory nerves. So these are the different perceptions of sound and how you have a noise exposure hierarchy. And then for doing scoping and baseline studies, you can use equipment like a microphone, sound level meter, and analyzer, different sound source. And then you have three type of settings in any sound measuring equipment. So slow or S weighing, that is you average, you take an average of approximately 1 second to measure noise levels. That is, it is relatively constant or it varies slowly. Then you have fast weighing, where you average your measured sound every point 1 to 5 seconds. So in this case, you observe more fluctuations in your noise levels. And then you have impulse weighing, which is you require specialist equipments which respond or record all of these sudden noise increases. So based on what sort of frequency or what sort of accuracy you want in your sound survey, you can set up these settings. And then for doing noise measurements or data collection, you need to identify the equipment which you are using, what sort of manufacturer the equipment has, the type of the equipment. You need to note the date, weather conditions, wind speed, wind directions. You need to calibrate the sound meter or microphone, that is the device, so that it records the correct data. Then you need to set up the microscope or the instrument at an appropriate site. Note this precise location in your geographical map where this data is being recorded from. And then you take measurements using the criteria from the relevant guidelines. You use fast weighings for traffic or slow for construction noise. Then you note the start and finish time when you were taking these recordings, and then you check for calibrations whether the data you get is correct or not. And for doing noise assessment, you need to identify. So basically, there are two purposes for doing noise assessment. The first is to identify the changes in noise levels, which may occur both in the short and long term. And the second is to determine the significance of this change. So, of course, any sort of construction activity is going to generate huge levels of noise based on the type of construction processes which are employed. So, you need to do this noise level assessment for your EIA project, anyways, if you're constructing something major. And so you have different variables like existing and likely future baseline noise levels. Uh, you have the type of equipment that is both fixed and mobile. Yeah. So you need to look up at the type of equipment, whether it is mobile or it is fixed, when you use it for measuring these noise levels, whether the duration of various stages of construction and operation. You need to identify the time of the day when the equipment was used, the actions which were taken by the in the site, the locations of the receivers, the sensitivity to noise. Topography of area, including the main landforms, land use and now natural sound barriers, the meteorological conditions in the area, that is the wind speed, wind direction, temperatures, the amount and type of sound which is coming from from the site. You need to identify the sources and the frequency of sound which was happening. The instrument is measuring all of these things, and how that sound travels, the response of the receptors, whether they were irritated, whether they noticed the sound while they were doing these activities. So these are the few variables which apart from the instruments you need to capture in your recording. And then this is an example of typical sound levels from construction equipments. So we have a bulldozer which has a sound level of 80 decibels. Then you have the let's say a large concrete mixer, which is again 76 decibels. Then you have a tower crane, which is again 76. The diesel generator, which is used for lighting in the site for working at night or in the evenings, so 65. So these are different sound levels from different type of equipments which are used in construction activities. And then you need to do certain calculations based on the type of source. So you can have a point source, that is one single object causing this noise pollution in your site. So you can calculate because of the distance of between the source and the receptor. So we have the sound pressure level, which is measured from the noise source in at a distance R2 from the source. So this is calculated by subtracting 20 log R2. R2 is the distance, and R1 is the distance from the noise source. Uh, and the sound pressure, you subtract this value, which is 20 log R2 by R1, which is the distance between point 1 and point 2. So R2 and R1 from the source. And then you subtract the sound pressure levels at for getting the noise pollution at point 2. You subtract the sound pressure level, you subtract this value from the sound pressure level at point 2, point 1, sorry. And then we have the line source noise. So the only thing which varies is the constant, which is it becomes from 20, it becomes 10, but the equation is same. So for the point source, the constant for subtraction is multiplied by 20, and for line source, it's multiplied by 10. Okay, and then you also calculate the sound power data, which is again this equation, so you can go through them. And there were a few numericals which you can expect around these equations. So they're going to be very straightforward. That is, they're just going to give you the values according to these parameters which you need to input, but you can still remember them for numericals and numerical MCQ questions. And so then for assessing the impact prediction and evaluations, we have calculations. So we have this guide, which is the international standard ISO 96132. And this was around acoustics attenuation of sound during propagation outdoors. And it talks about this general method of calculation of predicting outdoor sound or noise. And then we have different modeling softwares as well, like SoundPlan, CADNA. So these can model the sound effect being felt from different sources, which are again defined in your uh, project definition when you model them in these softwares. And then you can use traffic noise modeling, where you input certain parameters and then you get the calculated traffic noise. So again, you need to have different sort of inputs, and you need to put them in the model to get the output. Then you also have the criteria for determining the sensitivity, which is to
Hello. Excuse me, voice is not coming.
So then you need to look about all of these things around traffic movement or traffic assessment, baseline surveys. And then for doing a similar thing for rail and tram networks, you need to look up at the line capacity, whether it's a single line or it's connected by a return line as well. Then you need to look up at station capacity, stairwells, platform lifts, platform widths, the platform length, the passenger capacity, time delays at any railway crossings, layover capacity, proportion of freight trains versus passenger trains, the proportion of stopping or non-stopping vehicles and their speed. So these are things you need to consider around railway and tramways and metros. And then for development of cycling or walking infrastructure, you need to consider the pavement or sideway length, sideway width, the network standards, the destinations, whether there is connections between 2 points, whether this gets break, whether you have infrastructure existing at a certain limit only, and then you don't have any infrastructure, so the passengers then you have these disruptions to these movements. And then you need to look up at existing roads, the journey lengths, and the different user groups which go for cycling and walking facilities. And then for assessing the impact prediction and evaluation around transport methods, we need to look about air quality and greenhouse gases, what sort of emissions these traffic infrastructure is causing, from air pollution to carbon dioxide emissions, from dust from construction and their subsequent effects in the future as well. Because any sort of transport project you do, it's going to lead to more increased transport networks. So it will cause an increase in the number of cars and the increase of number of trains and things. And what sort of direct impacts it's going to have, you need to also calculate those impacts. That is the future projections of these things. And then you also have to look up at the communities and economic activities. That is what sort of people are going to use these new transport services, whether there's a loss of roadside community, business, and social activity. India especially has a lot of roadside shops and vendors which make their income or livelihood through these roadside infrastructure or through their roadside stalls. So you need to look up at how your activity is affecting these things as well. The reduced convenience of traditional and sustainable modes of transport, whether the new transport infrastructure is going to affect the walking, cycling, and other sort of modes of transport being disrupted, and whether it's going to cause further effects again. You need to look up at those things again. Then also, if your project is causing any cultural heritage because of damage to any heritage resource in the new proposed development transport network, so that also you need to assess. In terms of ecology and diversity, again, assessments need to be made. In terms of health and safety, whether death and injuries due to accidents will increase, or whether practices have been undertaken to have proper infrastructure which reduces the chances of accidents happening. So these are also aspects you need to consider. Again, if the project is causing the displacement of indigenous people, which are highly vulnerable people, which will not recover from the damage which is inflicted on them. So that also needs to be dealt with sensitively in your transport network project. And similar things again around different parameters on soil as well. What sort of soil assessment you need to do, because India, as it experience rains and things, you have cases where soil, you have the like soil displacement, that is soil, the road infrastructure, as well as the soil falls back into the ground because of the displacement of soil, which is की रोड धस जाता है जिसको कहते हैं. तो उस टाइप का you need to do that sort of assessments as well. And again, around water resources, whether you are making more permeable surfaces or impermeable surfaces, such that the rainwater is not going directly to the groundwater table, and this causes surface runoff of water. So the water cycle is not getting recharged and the rainwater is going into drains and causing urban flooding and things like that. So you need to consider that aspects as well. Landscapes and townscapes again. And then we looked at different softwares which were used for impact prediction. So we have the Saturn, we had the Bentley Transportation and Land Use Modeling, which was the EMME. Then you have Inzo, Omnitrans, Transcat, Transportation Planning Software. You have PTV, Vism, you have Picardy, and other softwares which can be used for predicting the impact of uh, uh, predicting the impact because of transport infrastructure coming up. And so now we will go to the question and answers from previous NPTEL course. So if anybody has any questions at this point, you can ask them now. We can take the questions later after the Q&As. Okay, does anybody have any questions so far? Okay, so we are going to move on to Q&A. So you can just put your answers in the chat box if you know these answers. And I will just keep moderating the chat box as well. Okay, so the first question is scoping purpose for establishing the ecosystem services, that is the ESR. Context for the planned project is based on the following. Likely impact sources, ecosystem likely to be exposed to change, beneficiaries who could be affected, or all of the above. So this is asking that when you do a scoping for ecosystem services, what sort of considerations you take where the ecosystem services are involved. Okay, so we have an answer D. So D is the correct answer. That is when we do a scoping to establish the ecosystem services context, we do an assessment of the likely impact sources, the ecosystems which are likely to be affected, and the beneficiaries who could be affected because of these changes. Okay, so moving on to question 2. So for baseline assessments of ecosystem services, following information are needed: the current level of ecosystem service supply, use, and benefit, the interrelation, the future supply and use in the absence of the planned project, taking account of existing threats and pressures and their relationships with people's livelihood, health, safety, and cultural benefits, or all of the above. So, what sort of considerations do we make, or what sort of information we gather to make a baseline assessment for doing ecosystem services review? Okay, so we have an answer D. So D is again the correct answer. So all of these considerations are important for setting up the baseline assessment for ESR. So moving on to question 3. So state true or false. Priority ecosystems are those for which changes due to a project are most likely to affect the well-being of beneficiaries because they depend on them to a great extent and have limited or no alternatives. So is the statement true or false? So priority ecosystems are basically ecosystem services, which are okay. Yes, so we have an answer A. So A is the correct answer. So these are basically ecosystems which are directly affected to a greater extent, such that the livelihoods or the economic dependency of the people or community or stakeholders is affected, and they have no other alternatives but to move or migrate from these ecosystems or to leave these ecosystems. So these ecosystems need to be dealt very sensitively in your ESR review, and mitigation efforts should be taken such that the effect on ecosystem services, which are the activities on vulnerable groups are dependent on are not disrupted or an alternative is provided to them. Okay, so moving on to question four. State true or false. Invest, that is integrated valuation of environmental services and trade-offs, is a software used to model trade-offs among environmental, economic, and social benefits so that decision makers can explore the implications of alternative land use scenarios. So is this statement true or false? So we looked up at invest in the module on environmental uh, ecosystem service review. Okay, we have an answer A. Yes, so A is correct. So this is again the model which is put forward by the Natural Capital Project, and they do this model to map and value the services or benefits which people get from the ecosystem, and they help these ecosystem services to be assessed such that trade-offs can be made in terms of environmental, economic, and social benefits. And you have different alternatives uh, for the effects for mitigating the effects which are being placed on ecosystem services. So A true was the correct answer as you stated. So moving on to question five, fill in the blank space of P and Q to complete the list in correct sequence of tidal zones. So we have one which is the sublittoral zone, then we have two which is Q, and three which is P. So P and Q can be either superlittoral or intertidal zones. So we looked up at this in the coastal geomorphology and geology presentation. Okay, so we have an answer which is correct. So B, so the topmost layer is the superlittoral zone, whereas Q was the one was as already printed was the sublittoral zone. So moving on to question six. So we have match the following, which is match the variety of coastal landforms given in group A with their description given in group B. So in group A, we have different sort of landforms, which are basically beaches, spits, dunes, and muddy shorelines. And in group B, we have image of the same as well as a definition for them. So you can take your time to read through them. Okay, so we have an answer which is correct. So beaches are basically, as you can see in the image, we have accumulations of loose sand or shingles that change shape in response to changes in the wave energy and maintain itself in the state of dynamic equilibrium with its environment due to the mobility of its sediments. So again, beaches are made up of sediments and the inflow of sediments because of the tidal movements. So beaches matches with two and the definition. Then we have Q, which is spits. So spits are basically when a coastline turns abruptly landward, such as when a bay or valley opens onto a coast. That is a finger line extension of the beach, and it may project out across the indentation. So spits are basically when you have these landforms or deposition of sediments in the water body. So it creates like these landward coast or a valley. So we call them spits because the coastal areas being split into uh, two two or more sort of uh, divisions. So the as the image shows, also these are this is what a split looks like. So matches with one, and then dunes are basically formed when there's a supply of dry sand and wind, which moves it to exist together. And these systems are usually fronted by sand beaches or sandbars, which are exposed at low tide, and which they have a close association. So dunes are when you have these sort of small ridges and valleys because of the movement of wind and sediments. So this is what a dune looks like as shown in figure in the option 4. And then muddy shorelines are when are common along the upper levels of the intertidal zone or estuaries, and these are shelter tidal embayments, and they form where tidal current velocities are too weak to resuspend completely the mud that settles at high water slag, and thus permitting the net accretion necessary to form mudlands and salt marshes. So muddy shorelines are basically when the instead of the beach sediments, you have like a muddy sort of uh, beach. So these are muddy shorelines. So S matches with C. So A was the correct option, as you pointed out. So moving on to question 7, state true or false. Single beam echo sounding and multi-beam echo sounding are techniques used for the collection of bathymetric data. Is this statement true or false? So again, we looked up at these techniques in the coastal geomorphology and geology uh, highlights. And okay, so we have an answer A. So A is the correct answer. So these techniques are used for collecting this data. So in beam echo sounding, you send a beam, and when it hits the landform underwater, it gets reflected back. So then you assess the distance of this landform uh, and the geometry of this landform. So single beam is when you send just one beam, and multi beam is when you send multiple beams to get a more accurate data uh, of the coastal geology. Okay, so A was the correct answer. So moving on to question 8, following are the impacts of urban development: A, runoff; B, soil erosion; C, nutrients and toxic pollutant loading in estuaries and marine water, which causes bioaccumulation and eutrophication; or D, all of the above. So these are basically the impacts of urban development on coastal regions. So if urban development happens in coastal regions, what sort of activities can happen? What sort of impacts basically result from these urban developments? Okay, so we have an answer D. So D is the correct answer. So because of urban developments happening, you have a lot more number of impermeable surfaces, which does not cause the water to seep down into the groundwater level. So it causes surface runoff. That is, this water goes into the drains and other water networks, and it runs off and does not recharge the groundwater. It causes soil erosion as well because of the displacement of the soil, and then nutrients and toxic pollutants are being discharged into the surrounding waters, which can cause bioaccumulation. That is the building up of toxic substances being consumed by species, and that species being consumed by another larger species, thus causing the increase of toxic content in the water ecosystem. And eutrophication is when you have an increased level of biodiversity at the surface level of the water body because of excessive nutrients being put into the water bodies. So you can see them in examples of lakes which have a large number of plant uh, population. So D was the correct answer, as you stated. So moving on to question 9, match the following terms given in Group A with their purpose given in Group B. So in Group A, we have impermeable barrages, and in Group B, we have permeable barrages. So these are basically structures which are created to prevent the movement or sort of control the movement of water. So things like dams and tidal power plants are examples of barrages. So you have basically a sort of structure which limits or controls the movement of water, holds the water, and allows the water to move in a controlled fashion. That is, you can control the movement of water. Okay, so we have an answer. So the correct answer is A actually. So impermeable mirages are when you don't have you don't allow water to go out of their stronghold. So these are used for flood defenses against high tides and tidal surges. So you just hold the water in the standing position, because otherwise the water will cause flooding and things in the low-lying areas. And permeable barrages are where you have this slot for getting water to move out such that it falls at a turbine which is located at a certain distance in the lower level. So that water, when it goes down, it causes the movement of the turbine, which generates tidal power, which is used to generate electricity. So it causes the movement of water to generate electricity. So permeable is when you allow something to move through it. So these are used in tidal power plants, whereas impermeable barrages are used for flood defense and drones. So A was the correct answer. So moving on to question 10. So match the following models for prediction of impacts of water and environment given in Group A with their application in Group B. So we have um, in Group A, we have models for prediction of impacts relating to water and environment. And in Group B, we have their application. So we looked up at these in the module on the coastal geology. Again, you can remember the purposes of the models and what sort of activities or applications they are used for. Okay, so the correct answer is C. That is the estuary models or the estuary dynamic models. They are used to simulate the tidal movement, currents, and discharge in shallow, vertically mixed water bodies, which are excited by ocean tides, hydrological influx, and wind action tides. And currents in the estuary are simulated. So these are basically dynamic models where you can change a lot of these parameters and see how all of these things impact the coastal zone. And then dynamic water quality models are used for simulating the mass transport of either conservative or non-conservative quality constituents for utilizing the information which is derived from the hydrodynamic model. And you can model up to 10 independent quality parameters, which can be coupled to determine the relationship for all of them together. So this is again a dynamic model where you can model up to 10 different parameters and see the effect. And then HEC2 is used for computing the water surface profiles for steady or gradually varying flow in both prismatic and non-prismatic channels. And SMS is used for lake circulation, saltwater intrusion, surface water profiling simulation models. So C was the correct answer. That is P matches with 2, Q matches with 3, and R matches with 4, and S matches with 1. So this is again match the following terms, and these are related to the definitions and concepts around noise. So in Group A, we have vibration, sound power level, sound amplitude, and sound frequency. And in Group B, we have their descriptions and their measurement units. So just a tip, if you cannot remember a definition, you can try to match the uh, units of the quantity. It has a unit and it is mentioned in the match the column group. Okay, so the correct answer is D. That is, vibration is the oscillation of an object about a reference point with the number of oscillations per second given by the frequency of vibration, which is hertz. And then sound power level is the energy output of a source, which is calculated from measurements made around the equipment under carefully controlled conditions. And then sound amplitude is the amount of pressure which is exerted by the air, which is often visualized as the height of the sound wave curve. And sound frequency is the air vibrates or how close the sound waves are to each other, and it is measured in cycles per second or hertz. So D was the correct answer. So moving on to question 12. So this is based on scoping and baseline studies for noise, includes the following. Identify relevant potential sources of noise. Identify the receptors, people, and resources likely to be affected by noise from the proposed development. 3, identify the monitoring location for baseline data collection. And 4, check the national, international guidelines and standards which should be applicable to the case. So which of the following statements are true relating to scoping and baseline studies for noise? Okay, so we looked up at them in the highlight section as well. So we have all of these statements are true and are considered when you're doing baseline studies for noise. So D was the correct answer. So moving on to question 13. So we have the basic equation given to calculate distance attenuation due to geometric dispersion by using the following method. So which of the following quantities is calculated based on this equation? So basically, what is LP1? So if you remember, we looked up at this in the noise calculations assessment. So this equation is used for calculating the sound power data. So A was the correct answer. So again, equations and calculations can come up in your final examination as well. So please make a note of them and practice some basic numericals around it. Moving on to question 14, with reference to the diagram, match the following trips in group A with their description given in group B. So we have different type of trips in group A and their description in group B. So you need to match the type of trips with its description. And we discussed this in the transport module as well. Okay, so we looked up at the Okay, so the correct answer is B, that is new trips are those which did not occur anywhere else on the transport network prior to a development relating to transport network. And then pass-by trips are those which are made part of another journey, such as stopping off on the way home from work. So you stop to get, let's say, milk because you ran out of milk. So that is a stop by trip or a pass-by trip. And then we have transferred trips, which is trips that are already being made and that would be transferred to the proposed development as well. So no changes made to this existing trip. And then diverted trips are similar to pass-by trips, but involve a longer diversion being taken from the existing route to the destination point. So B was the correct answer. And then this is a fairly simple question. So, which are the softwares used for transport impact prediction? So, we have Saturn, Cube, EMEE, all of the above. Okay, so we discussed all of these softwares in the transport impact prediction. So, all of these softwares are related to transport impact prediction. So, D was the correct answer. So, moving on to question 16, again, a question on transport related software. So state true or false. Software Picadi, that is priority intersection capacity and delay, is used for predicting capacities, queues, delays, both queuing and geometric and accident risks at priority intersections. So is the statement true or false? Okay, so the statement is true. That is, the software is used for making all of these predictions and for uh, assessing the proposed transport network. Okay, so moving on to week 9 assignment. So because the deadline for the assignment has passed, we are going to discuss the questions and answers to the assignment questions. So we have choose the correct order of components to complete the ecosystem service causal chain diagram as per our lender in 2017. So we have action, ecological indicators, benefits, relevant indicators, and benefits assessment. So what is the chain? So this is from ascending to descending. So the first step is first, and the last step is last. Okay, so we have an answer. So the correct answer is A, that is action. So first you look up at the action, and then you look up at the ecological indicator, and then you look up at benefits relevant indicator, and then you look up at the benefits assessment, that is whether a social value is being disrupted because of this because of the disruption to this ecosystem service. So A was the correct answer. So it all starts with the action that your project is having. Okay, so moving on to question two. In the context of EIA for ecosystem services, ESR refers to ecosystem service review, economic and strategic review, ecological system remuneration, or environmental service resilience. So, what does the abbreviation ESR refer to? Okay, so the correct answer is A, that is Ecosystem Services Review. So, ESR stands for Ecosystem Services Review. So, moving on to question three, state true and false. Precise estimates of current levels of ecosystem service supply, use, and benefit are essential for developing a reliable baseline for ecosystem services. Is the statement true or false? So we have an answer. Yes, the statement is true. So you need to assess the current level of ecosystem service supply, use, and benefit for developing the relevant and reliable baseline for doing your ESR. So the statement was true, as you stated. So moving on to question four, which of the following contributes directly to changing shorelines and coastal area? Is it A, tidal current, B, sea fish, C, fishing ships, or D, boating and surfing? So which of the following four options contribute directly to changing shorelines? Okay, so A is the correct answer. Tidal currents basically bring in the inflow of sediments and it takes some sediments out of it and it directly affects the shorelines. So A is the correct answer. So moving on to question six, state true or false. Coastal geomorphology directly impacts coastal erosion, but one should consider it for aesthetic purposes as well. Is the statement true or false? Okay, so this statement is true because a lot of these coastal zones are associated with tourism. So you should, in terms of considering the direct impacts like coastal erosion, you should also consider it for aesthetic purpose, like the satisfaction of tourists and other people who will be visiting these places, or and whether these if it's not maintained for aesthetic reasons as well, it is going to cause a decrease in the number of tourist influx coming in. So the statement was true. So moving on to question seven, dash is also known as tidal flats. So these are coastal wetlands that form when mud is left behind by tides or rivers, and they are found in sheltered regions such as bayous, lagoons, estuaries, and bays. Is it A, abyssal plain, B, mud flats, C, aphotic zone, or D, benthos? So these are the different types of coastal areas, and so the correct answer is B, that is mud flats. So we also look at mud flats as these areas where mud is left behind by tides or rivers in the coastal shoreline. So they are known as mud flats. Okay, so B was the correct answer. So moving on to question eight, which of the following are key approaches in identifying environmental impacts in coastal areas as per the methods of environmental and social impact assessments, Roy Emberton, Richard J. Wenning, and Jules 2018. So this is a multi-select question, so more than one option is correct. So you need to identify which of the options are correct and what sort of approaches are taken for identifying the environmental impacts in coastal areas. Okay, so the correct answer is A, B, and C. That is, you need to do public consultations with the key key stakeholders, that is people whose livelihood depend on the coastal zone. You need to do consultation with the key authorities and government agencies because they collect data on these things, and some of them are doing research in these areas as well. So you need to do a consultation with them. Then you need to review the survey data, and then you need to consult with the concerned authorities as well. So A, B, and C are correct, whereas you do not need the opinion of nearby city residents. Okay, so moving on to question 9. Arrange the following phases of hydrodynamic and ecological impact assessment in their correct order. So we have identification of effect and potential impact, description of effect and impact, assessment of effect and impact, and derivation of impact significance. So what is the correct order? Starting from step 1 to step 2 to step 3 and step 4, so on. Okay, so the correct answer is A. That is, yes, the all of these steps are mentioned in the correct order itself. So, as you correctly stated. So, moving on to question 10. So, you need to match the consequences of urban development in Group A with their impact on the environment in Group B. So, we have consequences of urban development and their impacts in Group B. So, you need to match Group A with Group B. Okay, so the correct answer is A, that is increase in surface runoff during heavy rains can cause flash floods. That is when you don't have enough infrastructure for facilitating the movement of heavy rainfall. It causes flash floods in urban areas wherein water does not seep into the that is the existing water channels are filled with water, and the water cannot go and recharge the groundwater, so it causes flash flooding. Then soil erosion causes sediment load, suspended sediment loads, and sewage discharge from urban areas causes eutrophication or increased density and production of plant species in the water bodies because of excessive nutrients being present in the water body. So A was the correct answer. So moving on to question 11, BS 52282, that is Bureau of Standards, 2019, indicates that construction activities generally only cause vibration impacts when they are located less than dash meters from sensitive locations. So the Bureau of Indian Standards have identified that construction activities have cause vibration impacts up to a certain location. So what is that location in meters, specifically for sensitive locations? So yes, the correct answer is 20. So the answer, the option B is correct, as you pointed out. So moving on to question 12, which of the following is an uncommon noise source in the context of environmental and social impact assessment, or ESIA? So which is an uncommon noise source? So you have road traffic, railway noise, construction noise, and crying children. So pretty straightforward question. So D, crying children is the correct answer, as you all said. So moving on to question 13. Match the correct units in Group B with what they are used for measuring in Group A. That is, Group A has the sound parameters, and Group B has their units in which they are measured. So again, units and their definitions are important of terms, and if they have any equations. So yes, B is the correct answer. So sound frequency is measured in hertz or cycles per second. Sound amplitude is measured in micropascals, and sound intensity is measured in decibels or dB. So B was the correct answer. So moving on to question 14, state true or false. Non-transport developments such as afforestation also require the EIA of transport to be considered as part of the complete EIA process. Is this statement true or false? Okay, so the statement is true. That is, if even if you do not have any transport development in your project, you still need to consider afforestation and do a EIA for transport because you will be making a lot of uh, let's say you need to make roads for the movement of uh, construction materials being brought up. And then for things like afforestation, when you cut or log off trees, you still need to make them, after you have cut these trees, you need to transport them to a different site. So you need to have EIA for transport to assess the impact of the carbon emissions caused after the cutting of trees or the afforestation activity has happened. So you need to do EIA for transport even for non-transport developments like afforestation because it requires a transport component assessment as well. Okay, so A was the correct answer. So that was all for the question and answer. So if you have any queries, you can ask them now. You can either put them in the chat box or you can unmute yourself and ask.
Hello.
Hello, yes.
Yes, ma'am. I am have a one query. Some assignments I cannot submit due to the some circumstances. Then it is what is the criteria for appearing in exam? Okay, how much assignments should be submitted before due date?
So I believe the assignment, there's no assignment criteria, but you have 40, I think 40% of your marks will be calculated from your assignment, whereas 60% will be, I think, calculated from your final examination, if I'm not wrong. I am not sure about what is the actual requirement. You can write to the NPTEL forum. Uh, so you get these emails from the NPTEL forum, which, for example, for this problem solving session, so you can write to them saying that you missed some of these assignments and what is the criteria. But as far as I know, 40% of your marks are calculated from your assignments, and 60% is calculated from your um, final examination. And then I think for passing, you need a certain benchmark, which I'm not sure.
Thank
So,
you,
but
ma'am.
you, yeah, you can write to them and they can answer your query much better. Okay. Does anybody have any questions? Okay. If there are no further questions, thank you so much for attending this problem solving session for week 9. And if you have any queries, you can put them in the discussion forums. And the video for these problem solving sessions is also available on YouTube, and these slides are being made available in a Google Drive folder, so you can access them even after these problem solving sessions before your examinations as well, if you want to refer to any of the concepts. So thank you so much. So I will now close this meeting.